thanks to Nikola Tesla, we have the alternating current, which is used to power to send power through long distances. And with his famous invention, the Tesla coil, which used to transmit electricity wirelessly, and we used that idea to for this project to light up a light bulb, basically. And the basic concept of it is that we send a direct current through a power supply, and it'll then get converted into an alternating current. And once that current hits the copper coil, it'll travel through the copper coil and it'll create a magnetic field. And once that magnetic field is created, you can put a light bulb in near the proximity of the magnetic field, and the light bulb will light up. And the closer you put the light bulb to the copper coil, the brighter the light bulb will be. That was too fast.
For this portion of the video, we're going to be explaining the build, not only how we made it, but some of the errors that we had along the way. This right here is our working Tesla coil. We have the transistor, we have the resistor, we have our power source, we have our toggle switch, and the tower for the secondary coil and our primary coil. Now the way this works is the power is sent from the battery all the way through the system. It gets sent to the primary coil, which is our green coil here. What happens at this point is that the current running through the coil will make a magnetic field. This magnetic field will then interact with the secondary coil, creating a much stronger magnetic field, which lights up our light bulb. Now, the primary coil here, the secondary coil in red was made out of magnetic wire, 26 gauge. For the secondary coil here, we also used magnetic wire, which this was 20 gauge magnetic wire. The transistor that we used, as explained previously, was a PN2222A resistor. Basically, at this junction, what happens is the current essentially becomes alternating current, which moves the charge through the actual primary coil, which causes the magnetic field. Now, some important things about this. The resistors, we ended up changing it. Originally, we had it set up like this, where we had, I believe it's 8 or 9 resistors in series. We soldered them together for a total of 28,500 ohms. Now, what we ended up realizing was that one of the possible errors that could have happened in our build was that maybe one of the soldering connections wasn't solid as we would want it to be. However, we went and tested that theory. Turned out that it was too much resistance. What we ended up doing is we turned down the resistance here to be 22 kilo ohms for the resistance in the new working Tesla coil. Now, one of the other mistakes that we made for the build was that we had used Cat5 Ethernet cable for our secondary coil. But what actually happened there was that the coils, we stripped all the casings off of it, and the coils ended up shorting out. Because what was happening was, as the current is running through these coils, it's actually causing little shorts in between because there's too much contact. The electricity jumps back and forth, or the current jumps back and forth, creating all these kinds of shorts, which didn't allow it to function properly. Also, for our primary coil here in green, another mistake we made was that we ended up using a an extension cord, an old one. We ended up cutting it up into pieces, and we made one, and we wrapped it around as our primary coil. However, the casing for this coil appeared to be too thick to allow to induce a current in the secondary coil. Let's see here. Another thing that we did, the transistor, we found out that they were actually very delicate, and the transistors, we had to make sure that when soldering them, we soldered them with very little time with the iron actually on it. Also, for the toggle switch, we scavenged some parts off remote control car that we had lying around. The toggle switch wasn't as reliable as we would have liked it to be. Also, the connector for the 9-volt battery also came off that toy, which turned out not to work as well. So, in essence, when making a build, make sure you buy new parts. It would make your life a lot easier. Thank you.
In this next portion, I'll be explaining our Tesla coil and the operation and a technical schematic of our Tesla coil. To begin with, our Tesla coil is actually a variation called a switch solid state Tesla coil, and more specific, a single resonant solid state Tesla coil, because the solid state component is this transistor. Okay, for our components in our schematic, this is the battery, the resistor, and before the resistor, there's a portion that goes to the primary winding that goes into the collector of the transistor, and then the resistor goes into the base of the transistor, and then the emitter goes to the negative portion of the battery denoted by the symbols, also which is good for the secondary windings. Okay, for one of the most important components of our circuit is our transistor, PN22228. The transistor is mostly made of silicon, and it's NPN type for this model. NPN means negative, positive, negative. And the way this is obtained is by a process called doping. Doping involves putting in impurities in the designated portions of our transistor. This portion is for the emitter, this one is for base, and this one for collector. Alright, once we operate our Tesla coil, voltage will be applied through the resistor. We will actually be making a current from the collector to the base, which will be raising the voltage on the base. Once the base gets a voltage about rated at 6 volt, that will allow a current flow from the collector to emitter. And as the current goes up, the voltage difference between the collector and emitter will be going down down to 0. Once this happens, the resistance also between the collector and the emitter will go down to 0. And while this is happening, current from the collector to the base was diverted to the collector to the emitter, causing the base voltage to go down. Once it goes down to a certain cutoff voltage, that will stop the current from the collector to emitter until the base voltage goes up back to its 6 volt rating. And this will be repeating itself again, current going back and forth. While this is happening on the primary coil, the magnetic field will be forming, which will be acting upon the secondary coil. Since the secondary coil has more windings, we'll actually have a higher voltage rating. And since there'll be a higher voltage, once we put in our light bulb, the light bulb will sense a voltage and it will illuminate. Along with